Today we're going to be discussing multiplying and dividing rational expressions. And just like rational numbers involve fractions, rational expressions also involve fractions of polynomials. And all of those rules of fractions are going to still apply when we cover rational expressions as well. So in particular, this first part, if we have all of these fractional numbers, recall that we multiply across the numerators, multiply across the denominators. We want to make sure neither denominator is equal to 0 because we're not allowed to divide by 0. And then we can call it a day. Just multiply across the top, multiply across the bottom. You're going to be doing the same thing when it comes to rational expressions. The thing that's going to be a little bit different is you first want to factor the numerator and denominator. And then you want to multiply your numerators together, multiply your denominators together, and then you want to ask if anything simplifies. And remember, with the simplification, if I had something like x plus 1 over x plus 1, that's going to just make 1. Anytime you have anything divided by itself, that's going to divide to make 1. So let's take a look at an example here. So if I had x plus 2 over x squared plus x minus 42 over x plus 7 over x squared minus 4, first thing you would want to do is factor. And in particular, both of these denominators are going to factor. So x squared plus x minus 42, you want to ask yourself what's going to multiply negative 42 and add to 1, since that x by itself secretly has a 1 in front of it, and that would be positive 7 and negative 6. For x squared minus 4, that's a difference of squares situation where you have x squared minus 2 squared, so that's going to factor into x plus 2, x minus 2. Then when you multiply across the top, you're going to want to make sure that you toss on some parentheses there if they're not already there, because that's the entirety of x plus 2 times the entirety of x plus 7 to make x plus 2 in parentheses times x plus 7 in parentheses. Then you're going to note what's going to simplify, and in particular, wherever I have something divided by itself, even if it's in a different order, at some point I'm still doing x plus 7 divided by x plus 7 and x plus 2 divided by x plus 2. Those are going to cancel out to make 1. And whenever the whole numerator cancels out, you're going to be left with literally just a 1 on that numerator, and then on the denominator there would be those remaining factors. So let's take a look at another similar example. So what we're going to want to do here, first of all, is toss on some parentheses where they aren't already. Then I'm going to notice that this part of this denominator should actually factor further. So I'm going to factor that into x plus 2 over x squared minus 9 is the same thing as x squared minus 3 squared. So that's the difference of squares where he's going to factor into x minus 3, x plus 3 times, and then we've got x minus 3 over x plus 5. Now I'm going to multiply across my numerators, which is going to give me with x plus 2 over x minus times x minus 3 all over. Multiply across my denominator, x minus 3, x plus 3, x plus 5. Notice how I'm not making my life more difficult and trying to FOIL this all out. That's not the point. The point is to really understand how these fractions are playing with each other. Then I'm going to notice if anything's going to simplify, and in particular x minus 3 divided by x minus 3 is going to make 1. And what I'm going to be left with is x plus 2 over x minus 3 times x plus 5. Now if the particular problem wants you to then FOIL out and redistribute that denominator, go ahead and do that. Otherwise, for most classes, I think that would be considered a nice, beautiful, simplified form. So I'm going to encourage you to pause your video and try these next 3 problems yourself, and then we'll go through them. So for these next 3 problems, we're again going to want to start with factoring if we can. So in particular, on the top, I notice that's going to factor into 3 parentheses p minus 1, because 3p minus 3, that does have a greatest common factor of 3, over, and then we're just going to have a p there on the bottom, times the second numerator is already factored as 7p squared, over, and then for 8p minus 8, that's going to factor into 8 parentheses p minus 1, since 8p divided by 8 gives you p, negative 8 divided by 8 gets you negative 1. Then we're going to multiply across the top, multiply across the bottom, so whenever I multiply those numerators together, we're going to have 3p minus 1 times 7p squared, over on the denominator, we're going to have p times 8 times p minus 1. And now I'm going to want to simplify a little bit. In particular, p minus 1 divided by p minus 1 is going to simplify to make 1. I might want to actually multiply those coefficients up top to make 3 times 7 is 21. We also are going to notice that p squared divided by p is going to make 1p, in the same way that x squared divided by x is x. So then I'll still have 1p left on the top, and then the only thing left in my denominator is going to be 8, for a final answer of 21p over 8. Let's go ahead and try the next one. So for the next one, again, we're going to want to make sure that we're doing lots of factoring from the get-go. So in particular, I'm going to focus on this very first numerator first. If I've got x squared minus 11x plus 30, what I want to multiply to is 30 and add to negative 11. And in particular, that's going to be x minus 6 times x minus 5, because negative 6 plus negative 5 makes 11. Negative 6 times negative 5 makes positive 30. Over on that denominator, we've got a greatest common factor of x squared. And then what would be left? Well, 3x cubed divided by x squared leaves us with 3x. 2x squared divided by x squared is going to leave us with 2 times. And then I'm going to simplify my other fraction. We're going to have 9x cubed minus 4x. That has a greatest common factor of x. 9x cubed divided by x is going to leave us with 9x squared. 4x divided by x is going to leave us with 4. And then in 4x minus 20, their greatest common factor is 4. And then 4x divided by 4 leaves us with x. 20 divided by x is going to leave us, 20 divided by 4 is going to leave us with 5. Now I hopefully also recognize that there's actually just a little bit more factoring itself that can actually happen. Because in particular, with 9x squared minus 4, that's the same thing as 3x all squared minus 2 squared. So I should hopefully recognize that that's a difference of squares. So I'm going to actually further factor this at the same time that I am, let me actually just differentiate these problems a little bit better there. I'm going to further factor that at the same time that I go ahead and just multiply my numerators, multiply my denominators. So 9x squared minus 4 would then factor into 3x minus 2, 3x plus 2 for those difference of squares. Since 9x squared is 3x all squared, 4 is 2 squared. And then I'm going to go ahead and just note all of those other factors as is, as I multiply across the top, multiply across the bottom. And I'm just even writing it in the same order for now. Now I want to note what's going to simplify. So in particular, I've got a 3x plus 2 being divided from a 3x plus 2, and 3x plus 2 divided by 3x plus 2 is just going to make 1. I also have an x minus 5 divided by an x minus 5, so that is similarly going to divide to make 1. And if I have an x divided by x squared, that's going to leave us with a single x in the denominator. So when I simplify this out, the only things left in my numerator are x minus 6 times 3x minus 2. And in my denominator, x times 4 would probably just be written as 4x. And that would be our nice, beautiful, simplified form. Keep in mind, whenever it comes to domains still, if you were asked about that, that's still on the original before you simplify. So for example, x would not be allowed to equal 5 because before I simplified, x minus 5 was in the denominator. So do keep that in mind if you are asked about domain. Let's go ahead and try this next one. So for this next one, again, same thing. I'm going to want to factor as much as possible. So for y squared minus 49, that's the same thing as y squared minus 7 squared. So that's going to factor into y minus 7 times y plus 7 all over 7y plus 49 has a greatest common factor of 7. 7y divided by 7 gets us y. 49 divided by 7 gets us plus 7. Times y minus 1 is already factored. For 7 minus y, I would actually recommend going ahead and factoring out a negative 1 and writing it the other way around, because since everybody else has written y first, if anything is going to simplify, it will simplify if there was also a y written first here. So just to kind of make that explicit, We know that 7 minus y is the same thing as negative y plus 7. Tomato, tomato, 1 plus 2 is the same thing as 2 plus 1. So I can go ahead and rewrite that as negative 1 times, and if we take negative y divided by negative 1, that leaves us with positive y. Positive 7 divided by negative 1 gives us negative 7. Then we're ready to go ahead and multiply across the top, multiply across the bottom, and as you've probably noticed by now, that just effectively makes that fraction bar extended, so I'm going to do that for now, and then we're going to note what's going to actually simplify. So in particular, I also wrote one of my 7s really messy, even though I did note it was a 7 up here, my bad. Whenever we were factoring, in particular, y squared minus 49, I physically said y minus 7, y plus 7, and I wrote that 7 as a 1 for some reason, which was really smart of me. And part of the reason why I know I did that wrong was because then I notice here that we've got y plus 7 divided by y plus 7 is going to make 1. Y minus 7 divided by y minus 7 is also going to make 1. So what I will be left with as my final answer is still in my numerator is y minus 1. And in my denominator, 7 times negative 1 will give me negative 7. And that would be my nice, beautiful final answer. When it comes to division of these rational expressions, we're going to want to make it look like multiplication. In particular, recall that dividing by a fraction is the same thing as multiplying by the reciprocal. So in particular, you want to what's called keep change flip. So if, for example, you have 1/3 divided by 3/4, you're going to want to keep change flip that to 1/3 times 4/3. And this original restriction, all they're saying is anything that will end up in a denominator in some point in your process better not be 0 if you're going to be interpreting it this way. So in particular, you should not be dividing by 0 in any way, shape, or form. So let's go ahead and go through a practice example of that. So for example, let's say you want to divide 5m minus 5 over m divided by 6m minus 6 over 5m squared. So first things you would do is keep the first one the same, change the division sign to multiplication, and flip the second one to be its reciprocal. That would be your first step. So you want to change that division problem into a multiplication problem. Then from there, that's going to resemble exactly like the multiplication problems we were talking about before. So you're going to pull out the greatest common factor in this very first set of parentheses for 5m minus 5. That would be a 5. So you'd have 5m times m minus 5 times that 5m squared that's also in that numerator over m times, and then in 6m minus 6, its greatest common factor is 6. 6m divided by 6 leaves us with m. 6 divided by 6 leaves us with 1. Also, before 5 seconds ago, I should have also noted that for the 5m minus 5, when you're dividing by 5, 5m divided by 5 is 5. Negative 5 divided by 5 is 1. I don't know what I was thinking, write down 5. But there you go. Hopefully you caught me before I caught myself. And regardless, now that we're here, when we have m minus 1 divided by m minus 1, that is going to cancel to make 1. If I have m squared divided by m, one of those is going to cancel out to leave us with just 1m there in the numerator. And then 5 times 5 gets us 25. And then we still have a 6 left for that final answer, and that's all that's saying. Also just written out and typed nicely over there as well. So let's go ahead and look at another example of this. So the first things we want to do is change this to a multiplication problem. So that's 2x plus 6 over x squared minus 1 times, so we're going to keep the first one the same, change to multiplication, and then flip to be its reciprocal, x minus 1 over x plus 3. That's our first step. Then we want to factor as much as we can. So we're going to have 2x plus 6, that will have a greatest common factor of 2. 2x divided by 2 leaves us with x. 6 divided by 2 leaves us with 3. Times, and then with x minus 1, that's already simplified as much as it can be. X squared minus 1, that's a difference of squares situation, so that's going to be x squared minus 1 squared, so that will factor into x minus 1, x plus 1. And then the x plus 3 is already as simplified as it can be, so it'll just be rewritten. Now we want to note what's going to divide to make 1, so if I have x minus 1 divided by x minus 1, that will divide to make 1. X plus 3 divided by x plus 3, that will divide to make 1. And you will just be left with 2 over x plus 1 as your nice, beautiful final answer. Now keep in mind that that division still applies when it comes to just simplifying monomials as well. This still applies. Monomials are still polynomials, monomials being when there's just one term. So in particular here, if I was going to simplify this first one, I would go ahead and keep the first fraction the same, change the division sign to multiplication, and then flip the second fraction to become its reciprocal. Then I would multiply across the top, multiply across the bottom, and I would start to note where things would simplify. So if I have 50 times 30 times x to the 11th times y to the 3rd up top, which is all four terms that you got, over 30 times x to the 6th times y to the 8th, which is all four terms that you have on the bottom. When we have 30 divided by 30, that will divide to make 1. When I have x to the 11th divided by x to the 6th, that will divide to make x to the 5th in my numerator. When I have y to the 3rd divided by y to the 8th, that will divide to make y to the 5th in my denominator. And for 50 divided by 30, recall that those would have a greatest common factor of 10, so I would divide those both by 10 to be left with 5x to the 5th over 3y to the 5th is my nice, beautiful final answer. The next one, I want to do the same sort of thing. So I want to go ahead and note where this is going to factor. Well, First you want to go ahead and change it to multiplication, then we're going to factor. So we'll have z squared minus 81 over z, so first term the same, times, so keep, change, flip, set z plus 7 over z plus 9. Then we're going to want to go ahead and factor, so z squared minus 81 will factor into z minus 9, z plus 9, because that's the difference of squares situation, where that's the same thing as z squared minus 9 squared. And then we'll have the z plus 7 does not simplify, all over z times z plus 9. Then we're going to want to note what is going to further simplify. Z plus 9 divided by z plus 9, that will simplify to make 1. And so your final answer would be z minus 9 times z plus, let me actually just write this where there's more room. So your final answer would be z minus 9 over z plus 7 all over z. Those were the things that did not cancel out, and that is what you are left with. Now let's go ahead and go over two more final examples. So I'm actually going to encourage you to go ahead and pause your video and try both of these yourself, and then we'll go over them together. So if we're going to try both of these, so for this first one, again, since he is a division problem, you're going to want to go ahead and rewrite him as multiplication. So that would be x plus 3 over x plus 9, so keep the first fraction the same. Then change the division to multiplication, and then we're going to flip, so that would be 7x plus 63 over 6x plus 18. Now we're going to want to simplify this some more, so we're going to go ahead and factor anything that can be factored up top, anything that can be factored on the bottom. So that would be x plus 3 times, and then the greatest common factor between 7x and 63 is 7. 7x divided by 7 leaves us with x. 63 divided by 7 leaves us with 9 over, and then we still have an x plus 9, and then the greatest common factor here is going to be a 6. 6x divided by 6 will leave us with x. 18 divided by 6 is going to leave us with 3. Now we're going to see what's going to cancel. So x plus 3 divided by x plus 3 makes 1. X plus 9 divided by x plus 9 makes 1. And actually in this case we are literally just left with 7/6, which is kind of nifty. For this last example, we're going to have to do a little bit more creative factoring, but first we are going to see if we even need to change the equation. But don't be on automatic pilot. This is a multiplication problem. Nothing needs to be changed. You're just going to multiply across the top, multiply across the bottom. So don't forget that. Only do the keep, change, flip if he's division. He's just multiplication. We're good. So we're going to go ahead and factor. And I'm going to factor these ones where there's leading coefficient not of 1 off to the side. So for 3x squared plus x minus 4, we want to multiply negative 12 and add to 1, and that would be the numbers positive 4x minus 3x, because 4 times negative 3 gives us negative 12, and 4 plus negative 3 will give us a single positive x, and then we'll drop down everything else. Then we're going to want to make our two groups and pull out the greatest common factor of each group. Between 3x squared and 4x, their greatest common factor is x. 3x squared divided by x will leave us with 3x. 4x divided by x will leave us with 4. Negative 3x minus 4 has a greatest common factor of negative 1, which will just end up flipping the sign on both of those. Now they have 3x plus 4 in common, and x minus 1 is what is different that would be left after dividing out the 3x plus 4. So that means we've got 3x plus 4 times x minus 1 over, and then we want to keep on with our factoring. So for 3x squared minus 8x plus 5, here we want to multiply to 15 and add to negative 8. So in particular, we're going to want to split that middle term into negative 3 and negative 5, because negative 3 plus negative 5 makes negative 8. Negative 3 times negative 5 makes positive 15. Drop down your other terms. Then we're going to want to keep on going with the groupings. So we've got 3x squared and 3x. Their greatest common factor is 3x. 3x squared divided by 3x is going to leave us with a single x. Negative 3x divided by 3x will leave us with minus 1. Negative 5x plus 5, their greatest common factor is negative 5. Negative 5x divided by negative 5 leaves us with x. 5 divided by negative 5 leaves us with negative 1, because remember, if the leading term is negative, you do want to factor out that negative. Then we would have one parenthesis of what's the same, which is x minus 1, and one parenthesis of what's different, which is that 3x minus 5. So that denominator would factor into x minus 1 times 3x minus 5. And then we're going to keep on going. So we're going to multiply that by, and then that first numerator actually just factors really nicely, because that leading coefficient is 1, so I just need to ask myself what's going to multiply a negative 6 and add to negative 1, and that would be negative 3 and positive 2, so he's going to factor into x minus 3x plus 2. The last one, I'm still going to want to factor off to the side here a little bit. So he is, I'm just going to actually first write him down where I can see him, 3x squared plus 10x plus 8. Let's go ahead and factor him. So in particular, that 10x, we want to multiply to 3 times 8, which is 24, and add to 10. So the numbers that would multiply 24 and add to 10 would be 6 and 4. So we're going to split the middle term into 6x plus 4x, drop down the plus 8, drop down the 3x squared. Then we're going to make our two groups. The greatest common factor of the first group is going to be 3x. 3x squared divided by 3x will leave us with x. 6x divided by 3x will leave us with plus 2. Greatest common factor of the second group is 2. 4x divided by 2 is going to... Oh, actually, no, I lied. Greatest common factor of the second group is 4. Just seeing if you were paying attention. 4x divided by 4 will leave me with x. 8 divided by 4 will leave us with 2. And in particular, I knew I probably lied because those parentheses should work out to be the same. So that's how I knew to double check myself. So then our final answer would have x plus 2, what they have in common, times 3x plus 4, what is different. So I'm going to go ahead and write that final denominator as x plus 2 times 3x plus 4. Now I want to see, as I'm multiplying across the top, multiplying across the bottom, that's effectively just going to elongate this nice beautiful fraction bar, right? Because I'm just multiplying across the top, multiplying across the bottom. But I want to note what's going to simplify. In particular, 3x plus 4 divided by 3x plus 4 is going to make 1. X minus 1 divided by x minus 1 is also going to make 1. X plus 2 divided by x plus 2 will also make 1. And I would be left with x minus 3 over 3x minus 5 as my nice, beautiful final answer. So just to recap, whenever you have something written as multiplication, you're just going to multiply your numerators together, aka multiply across the top, and then multiply your denominators together, aka multiply across the bottom. Then you're going to make sure that you factor everything that you can factor, And then if you notice that you have the same factor divided by the same factor, you will be able to quote-unquote cancel that out, aka notice that doing something like x plus 2 divided by x plus 2 will make 1. Anytime you divide something by itself, that is going to make 1. If you are given a division problem instead, then you first want to do keep change flips. So you want to keep the first number the same, change the division to multiplication, and then flip the second fraction, aka notice that dividing by a fraction is the same thing as multiplying by its reciprocal, and then you're just going to handle it as though it's a multiplication problem from there.